I created a diagram to help me explain the atom composition of simple molecules. So for this composition of simple molecules, we have three types of particles: protons, neutrons, and electrons. Protons are the positively charged particles, neutrons are the uncharged particles, and electrons are the negatively charged particles that move around the nucleus. The nucleus is the combination between protons and neutrons. This is my example for the extended structure. It's detergent and it contains oxygen, hydrogen, chlorine, and carbon in a doubled benzene ring. For this part, I chose polymer as my synthetic material. It contains chlorine, hydrogen, and carbon. In order to make it, first you need to heat up the plastic to the point where it's softened or melted. Then you need to shape it into some desired shape and leave it there so it can cool down. I chose salt as my material to demonstrate the changes in particle motions, temperatures, and the state of pure substance when adding or removing thermal energy. The cup on the right has boiling water and the cup on the left has normal water. I will put in a scoop of salts in each cup, and let's see which cup dissolves quicker. So here, the cup with boiling water dissolved first because it has thermal energy, and particles tend to move faster in thermal energy, which is also called heat. As you can see, the paper was burnt. It turned into a blackish color and felt like sandpaper. This was a chemical reaction because new substances were formed and the chemicals inside of the paper were changed since I added energy to it. Here, I have an equation for burning paper. In this equation, a chemical reaction occurred which proved that the law of conservation of mass is correct because based on the equation, the number of chemicals stayed the same. The law of conservation of mass states that in a chemical reaction, atoms cannot be created nor destroyed, which means that the mass cannot change. I chose a stove to fry shrimp chips to demonstrate a device that releases thermal energy by a chemical process. The stove transfers the energy to the pan, which will then transfer the energy to the shrimp chips. This is an exothermic reaction. The chemical reaction in this clip is the part where the shrimp chips are being burnt, which is also called combustion. The reason why the stove was able to create heat was because the methane gas is being burnt by oxygen. Newton's third law states that when an object exerts force on another, the other object exerts the same amount of force back. So here you can see that the two balls are colliding against each other, and they both bounce back, which means that they both exert the same amount of force. For this example, I used a phone and a laptop to explain why an object's motion depends on the force and the object's mass. So here you can see that I had to use more force to push the laptop than the phone because the laptop weighs more, which means it has more mass. I used a textbook and a ball to help me demonstrate Newton's first law, which states that objects at rest remain at rest. Objects in motion stay in motion unless acted by another force. So here you can see that the ball is in motion and the book is at rest. The ball would keep moving if the book and friction wasn't there, and the book would still stay there if the ball didn't affect it. So for this part, I decided to draw out two simple waves so that I can explain how the wave's amplitude affect its energy. So as you can already see, the black wave has lower amplitude and the red wave has higher amplitude, which means that the red wave is going to have more energy and the black wave is going to have less energy. For this part, I will be giving you guys real-life examples of where you can actually see waves being reflected, absorbed, or transmitted through various materials. So let's start with the first one, reflection. You can see this on a mirror because light is being reflected by the mirror. Number two is absorbed. So every color light waves is absorbed by the wall except for the color white, and that's why you see white. The third one is transmitted, which means that light waves can move through an object. In this case, it's a clear folder, and that's why you can see through it. For this section, we will be talking about electric and magnetic. So let's start off with electric. There are three main factors that can affect electric: voltage, conductor, and the imbalance of charge. Voltage is the power or energy source. An example for this would be a battery. Conductor is the wire or connector. An example for this would be a key. And the imbalance of charge is the more the charge are different, the more the electricity. An example for this would be charges separates into negatives and positive charges. Then the negative goes to the bottom of the cloud and the positive goes to the ground. Then with static energy, the charges exchange. Next, let's talk about magnetic. The two factors that can affect magnetics are distance and the align of magnetic domains. For the distance, the closer the two magnets are to each other, the easier they can attract. The further they are apart from each other, the harder it is for them to attract. For the alignment of magnetic domain, it could be found in non-magnetic materials where magnetic domains are not aligned, while in a magnetic material, the magnetic domain are partially aligned in groups. I was able to prove that the magnetic fields are true using a magnetic stick and a metal surface. Even though the magnetic stick is not touching the metal surface, the magnetic stick is still attracting, which means that there is a magnetic field.